everyone, and welcome. Today, we are going to kick off the second week of K-Show with a tech talk about a new nucleating agent for thermoforming of polypropylene. My name is Marta Sanz. I'm the technical manager for EMEA, for plastic additives. And I'm going to introduce my colleague, Pazula Namati. He's the product line manager for Hyperform. He has a background in polymer science. He's been in the industry for a long time. Joined Milliken in 2018 in the textiles business and transferred to plastic additives in 2024, where he's currently now leading the Nucleating Hyperform platform. With that, I'm going to give the floor to Pazula to talk more about our new nucleating agent. Thanks, Pazula.
Thank you. Good morning, everybody. A few words about Milliken to start. If I think about Milliken, I see it's a global and innovative company. We are in 70 different locations, more than 7,000 associates in 15 countries. And as you can see, our product goes to a variety of applications. In the core of it is material science-based innovation behind. So we have, I think that's in the gene of Milliken. Sustainability is definitely a core for the company culture. We have been proud to be a 19th time honoree of world's most ethical company in science-based targets, one of the first 50 companies in that. EcoVadis rated at gold, and I'll not read through all of those, but as you can see, sustainability is definitely a priority in our company, right? And I want to spend some time to discuss about this slide, about the partnership. As you can imagine, we are an additive supplier in the plastic additive business, but we work with a quite variety of different stakeholders in the value chain. And this is very important for us to innovate. As an example, the demand for what is a good product normally comes from the consumer. Consumer gets to the brand owner. The brand owner gives that demand to their suppliers. So for us to meet that, what consumer really wants to meet, what really wants to get, we need to work with different partners to get it right. So there's additive will impact the resin's performance. Resin design will impact the resin performance. The process will impact the resin performance. All these three will make a good product, and this good product should meet consumers' demand, right? So with that mindset in mind, we always work with different partners in the value chain. And in the booth, you can also see we have co-promotion with different partners in the industry. And today in the slide, we'll have a business case about a part that we made with our partner, PureCycle. Our nuclear business is in different applications. The main ones are for the thermoforming food packaging applications, the injection molded durable goods or automotive ICP applications, and also Homo PP for twin applications. Beyond that, there are some other small applications, but these three are the main ones. And we have several products that is specialized for different applications in different segments. And today we're going to focus on thermoforming parts, right? We have already two products that we sell in the market, which is called Hyperform 600 EI and Hyperform 68L. And these products we have been selling globally since 2005, 2008-ish. It depends on the region. And 58EI, it's our a new product that we are launching in this K-Show. At the core of it, Milliken believes in isotropic shrinkage. So I think if I want to summarize what is the most differentiated value for Milliken nucleator versus others, it's isotropic shrinkage. We believe that is very important for the industry. And all 600EI, 68L, and our new 58EI have these properties, right? And I'll mention a bit more why it is important, but in general, it improves production efficiency. Let's dive a little bit deep in thermoforming. This is a brief chart about how the process would work. Right, there is a sheet extrusion part, and there is thermoforming and making the parts part. And our nucleator, or not the nucleator in general, works from the extrusion. When the resin gets melts, it starts to work here. When the resin sheet start to contact the calendar and start to cool down, when the resin comes to the crystalline temperature, that's where our nucleator start to help the initial crystal to shape, right? From there onwards, crystal will grow, and you will really see the impact or the effect of the nucleator is working around this part, where we call there is a frost line, and you see the sheet will become a clear differentiations between a hazy part and the clear part. And then you visually you don't see much difference until the part is being made, but the crystal growth is happening throughout the entire process, and even after part is being made for even a few days. Right? So the nucleator will help not only haze is one part, clarity, gloss, these kind of optical properties, and also improves physical properties, bidirectional stiffness, shrinkage. This can also be improved by nucleator, right? And this is an impact on sheet, and also then that will further have an impact on the parts that's been made with that sheet, right? So nuclear is important for thermoforming the polypropylene. But then what nucleator should we use? In the market, there's two main nucleating technologies. One is from ours, another one is from our competitors. Today, for thermoforming, if you think about it, we can simply summarize it in this way. So our nucleator technology, 600EI, have, as I said, the isotropic shrinkage benefits. It shrinks evenly in machine direction and cross machine direction. And we have, across the board, aesthetic enhancement technology that makes the part, given the same haze, looks even better. And application-wise, quite a lot of our application goes to food application. So we have FDA coverage, but the FDA coverage is different than another FDA coverage. And our nucleators have a broader FDA coverage. 600EI is from A to H, whereas our close competitor is from B to H, right? And the rest is more or less the same, and we have to admit that our competitor is doing a good job in part haze. So their part haze performance was better than our nucleated technology. And this is where our newest generation of nucleation technology comes. 58EI still keeps our flagship advantages of isotropic shrinkage, aesthetic enhancements, and broad FDA coverage. I'll even mention later, it's even broader than last one. But in the same time, keeping our advantages, we reduce greatly, or the gap between ours and our competitors in terms of part haze. So we are catching up on that part haze. So it makes this nucleator an overall well-balanced performing nucleator in the market. Right. So that's an overall general information. Let's see some numbers. Of course, the nucleator works in different resin slightly differently, but within the house resin that we have, we were able to achieve a very similar part haze result versus the close competitors, right? And this is what we call about ovality and this isotropic shrinkage. As you can see, our competitors' nucleator shrinks a bit more, especially in TD direction. And ours, it's machine direction, TD direction is very similar. And why is it important? Because that will impact ovality of a part. Think about the drink cup part like this. You want the cup to be as round as possible. But you may say, I don't see in the market less oval parts, even from the competitor. It's because in the process, you can adjust the process to make it still oval, perfectly oval to your standard. But the drawback of that is if the nucleator doesn't shrink isotropically, you will need more time to get it more oval, right? So that's why the isotropic shrinkage can help our customer to reduce cycle time to get more parts made in the same time. So that improves the efficiency. And with one test we did, we were able to improve 22% efficiency in a given operation, right? This is to talk about our aesthetic enhancement technology. Haze is definitely very important to make the part appealing, right? We want to have less hazy parts, but giving the same haze, there is also another angle to further improve the aesthetics of the parts. Because the PP comes naturally with slightly a yellowness color, right? That when you stack it together, it doesn't look very nice. Even the haze is the same, because of the yellowness, it's not that appealing for the consumer. So we have an aesthetic enhancement technology to reduce that yellowness. As you can see, we have a yellowness index. In the fresh part, our yellowness index, it's way lower than our competitors, and even more than the control. And this is even more important in the thermoforming technology, thermoforming process, because thermoforming, as you can imagine, will generate quite a large amount of regrinds, right? So during the process, you make a cup, and then all the surrounding parts, you have to go back to make it regrind. And we understood the more times you regrind the PP, the more yellow it gets. With our aesthetic enhancement technology, we tested how does it look in the first pass, the fresh part, how does it look at the fifth pass, and how does it look at the eighth pass. And you can see not only in the fresh parts, our technology with aesthetic enhancement technology, it looks better, but over the time that you regrind more and more times, it always keeps the advantage, right? But generally, you see it becomes more and more yellow. This is just a picture to share how does it look when it stacks together, because it's quite important when you have a shop that you stacks like these cups together also. This is a cup we made with a partner in Taiwan. And this is to share how does it look. And I have a part that I would like you to also have a look. This is a part that's going to be distributed so that you can have a look. Is a part we made collaboration with our partner PureCycle. PureCycle, perhaps the audience already knows, they are a chemical recycling company, and this specific parts have 30% of PCR in it, right? And getting the with the PCR in the resin, it's quite challenging to get the haze well. And as you can see, with our 58 EI, we were able to improve haze by 29%. And aesthetically, I say it's as a 30% recycled cups, it looks quite appealing already. And this slide, I want to quickly touch base about FDA coverage. As I mentioned before, FDA approved nucleator is different than another FDA approved nucleator. As you can see, FDA have from A to J different criteria. So our competitor is also FDA approved, but they are approved from B to H. And our 600 EI, the previous product, was approved from A to H. And then now the 58 EI has the broadest coverage. We cover all the categories from A to J. This product is not only FDA approved, we have EFSA approved already. And we are in process of getting the China GB approved. We are expecting by the end of the year, we'll get also a China GB as well. Right, in the summary, if I compare the performance, the benefit of 58 EI, it's mainly comparing to par haze. It's mainly an improvement in the par haze from our previous generation. It's very similar to our competition. And in the rim ovality and isotropic shrinkage and broader FDA approval, we are better than our competitor, similar to our the previous generation. Right? It's a brand new chemistry. I just want to mention this point. Nowadays, launching a brand new chemistry is becoming more and more difficult because of all this regulation costs. But Milliken was still investing in brand new technologies in this industry to get the customer desired performance. Okay. I think that's it from my side. Please, if you have any questions.
Yeah, thanks, Pazula. Thanks for this introduction to 58 EI and how it can help thermoforming of polypropylene. I have one question, Pazula. Yeah. So you were telling us about the additional FDA approvals that we have with 58 EI compared to 600 EI, and specifically the last one, the J approval. Can you comment a little bit more what it means in terms of applications? Where can you use nucleated PP with 58 EI? What does it mean in terms of usage?
So if we see that, let me go back. If you see that coverage, J, it's in this FDA approval, it's one of the most difficult criteria in terms of temperature. So A already covers up to 120, actually, 120 degrees. J goes beyond that. So in a way, it's trying to prove that this material can withhold higher heat, right? And what does that mean is, imagine there are more and more semi-cooked food in the supermarket, that you put it in the microwave to cook it. In Asia, you have people cooking rice in the microwave. Here you have some soups that you heat like 7-8 minutes. Partially is heating, partially cooking, some sauces, some frozen foods that are not cooked. If it's already cooked, you just need to reheat, it's already in the H. But if it's semi-cooked and you want to cook it at a slightly higher temperature or longer time, that falls into J. Right.
Thanks a lot.
Thank you all.
Everyone for the attention.
Thank you for the good question.